Good morning. My name is Jabez Flores. I am a senior lecturer for UP Open University and an environmental consultant and drone pilot. Today, I will introduce to you GeoNadir and the concept of drone mapping and how we can use this for the conservation of forests over limestone in the Philippines. Like my previous lectures and workshops on drones and drone mapping, I will start the discussion by introducing you to the world of drones. And then I will show you some tools for analysis, how to analyze images qualitatively and quantitatively. And then I will introduce to you GeoNadir, the online software that I am currently using. And lastly, I will present some applications of these technologies in forest over limestone research. An unmanned aerial vehicle, or UAV, is an aircraft that is operated without a human pilot on board. They can be remotely controlled manually or flown autonomously using pre programmed flight plans. A drone is a general term for UAV. It refers to remotely controlled vehicles on land, water, or air. The term is mostly used for UAVs. The recent emergence of commercial UAVs or drones in the market has led to the widespread use in the film, events, tourism, and real estate industries. In agriculture and the natural sciences, drones are used by farmers and scientists for the purposes of mapping, monitoring, landscape planning and management, and application of fertilizers. The use of commercial drones in research methodologies and mapping workflows can provide students and researchers with a unique perspective of the world that was not possible a few years ago. In this era of climate change, we need to map and monitor a lot of things because conditions on our planet are changing at a rapid pace. With drones, planning, decision support, and on demand data collection in inaccessible and large areas are made possible with the aid of aerial imagery captured by a single drone pilot. Along with smartphones, laptops, and digital cameras, drones should now be an essential tool for research. And if you want to have a license, you should enroll in a drone school. Drones can be used in many ways. Military forces have been using drones since World War I for surveillance and reconnaissance missions. The popular use of UAVs began in the 2000s when it was made commercially available by companies such as DJI. Applying UAV technology in agriculture is seen as a solution to optimizing farm production and in addressing food security. Drones are also used for delivering supplies. Drones have different cameras or sensors that collect data and detect objects on the ground. For commercial drones, we typically have RGB sensors or our usual cameras that can see visible light. And we also have special cameras with powerful sensors that can detect heat, like the thermal camera, can determine elevation, like the LiDAR, or detect diseases in plants, like the multispectral and hyperspectral cameras. Some uses in research include the following: site survey, planning and design, land use and land cover monitoring, surveillance, disaster response, health and epidemiology, science communication, and ecotourism and agri-tourism. Aside from aerial images, drones can also produce specific data products such as orthomosaics, georeferenced 2D and 3D maps, 3D models, drone observations record, and digital terrain and digital surface models. To help us analyze these data products, we can use qualitative and quantitative tools. A guided aerial visual assessment is a qualitative tool to analyze drone images over a long period of time. This is a drone image taken by the DJI Rise Tello at 10 meters. What landscape elements can you see here? These are some elements identified just by looking at the photo. We can quantify this information using this table. Now we have baseline data derived from a single drone image. The guided visual assessment helps us identify what to look for. Now let me introduce you to GeoNadir. GeoNadir helps us address multiple challenges with drone data: storage and management, processing, analysis, and collaboration. GeoNadir can store both public and private datasets. It operates using the FAIR principles of findability, accessibility, interoperability, and reusability. Researchers can download public datasets for free and use them for their own researches. Here is an example of a dataset in Indonesia. This is a permaculture farm we studied for a project. The dataset is also accessible to the owners of the farm and to those who want to study permaculture. Now let's take a deep dive into how to use drones in our topic of interest, which are forests over limestone. Based on GeoNadir's Fair Global Map, we only have a few public datasets available in the country and none in Samar, Northern Samar, or Eastern Samar as of this webinar. Due to this limitation, we will use a proxy dataset for our demonstration, one that also has a high density of trees similar to a forest over limestone. I chose a dataset in Sagada and Tayabas as candidates for analysis. The Sagada dataset was collected by Malvin Figueras, while the Tayabas dataset was collected by myself and Ben Francia, the owner of the permaculture site in Tayabas called Habilin Farms. I need a high resolution dataset for this demo, so I checked the ground sampling distance or GSD of each dataset. GSD is the distance between the center of two pixels. You can find this information embedded in each dataset available in GeoNadir as seen on the slide. The Sagada dataset has a GSD of 3.56 centimeters, while the Tayabas dataset has a GSD of 1.45 centimeters. I chose the smaller value so it can give me the highest spatial resolution. Therefore, I will use the Tayabas dataset as proxy data for the remainder of this webinar. This dataset contains 687 individual images taken at an average altitude of 53 meters. These images were uploaded in GeoNadir and took around 2 hours to process the data. Processing involves uploading, storing in the cloud, stitching the images, georeferencing and overlaying the final orthomosaic on a satellite image, and extracting elevation data. This is all done automatically by GeoNadir without installing anything in your computer or saving images on your hard drive. The processing produced two types of digital elevation models: the Digital Surface Model or DSM and the Digital Terrain Model or DTM. The DSM includes the landscape elements on the surface, while the DTM removes those and only considers the ground in the visualization. This is called a Viridis color palette, where the lighter colors indicate high elevations, while the darker colors indicate low elevations. Using these models, we can visualize the heights of individual trees. In the GeoNadir project workspace, we can import other vector data layers as well, such as contour lines, boundaries, waypoints, and GPS tracks over the orthomosaic or DEM. In addition to vectors, we can also add geotagged ground photos or aerial photos to provide more context in our orthomosaics. We can take photos of individual trees at the ground level and see them in the context of a map using the Inspect tool. You can see the photo icon geotagged on the exact location where the photo was taken. This can be helpful for plant inventory studies. I tried this method in UPOU to locate the edges of a boundary from a vector file. Using the Google Earth app and GPS Map camera app, I was able to take a geotagged photo and upload it to GeoNadir. This is how aerial and ground photos can help each other. I got this idea for extracting tree growth data from a mapping mission in the Amazon rainforest using Pix4D Matic. Using the DSM, we can see mature trees, grassland, soil, and built structures. Using the enhanced contrast tool of GeoNadir, these features can easily pop up, and then we can classify these areas using the AI powered Magic Wand tool that auto segments landscape features. Using this technique, we can find disturbances within the forest over limestone while monitoring tree growth. If we want to extract the height of individual trees in the forest, we can use the height calculator tool and inspect tool. When we use the height calculator, a height layer will be created. Then by clicking on an individual tree, we can see the coordinates and the height in meters. This tree is estimated to be 15.42 meters in height. Using the DSM, we can also estimate the crown diameter of each tree. The enhanced contrast tool and the magic wand tool makes it easier for the user to digitize the object of interest. Once segmented, GeoNadir provides an instant measurement. This tree has an estimated crown diameter of 10.52 square meters. For analysis, we can use the compare tool in two ways. First, in this example, we are comparing a drone dataset with a satellite image base map. By swiping, we can see the difference between the resolution of the two images and the spatio-temporal changes that occurred. Second, we can also compare spatio-temporal changes between two drone datasets. This is an example in UPOU comparing a grassland in May 27, 2024 and in October 7, 2024. The more recent dataset shows greener vegetation. Second, we can also compare. Another way to analyze a forest dataset is to use the greenness index or GI. This tool can be used to determine vegetation vigor in the forest. This index is different from the more well-known NDVI or normalized difference vegetation index. An expensive multispectral camera is needed to collect the necessary bands to compute this index. However, when a multispectral camera is not available, we can use the RGB sensors of a commercial drone to capture the GI instead. This can provide proxy data for initial assessment of vegetation health based on visible light bands. Lastly, using the inspect tool, we can view the value of each pixel. The change detection tool can give us a visualization of two different drone datasets. The change detection can either be based on the greenness index for vegetation, digital surface model, or digital terrain model. Using this method, we can instantly see which areas on the landscape underwent significant change over time. Darker colors indicate more change, while lighter colors indicate less or no change at all. We can also do segmentation and classification using GeoNadir. I selected a specific area in the Tayabas dataset where there are visible differences on the landscape. Using the Magic Wand tool, I collected samples or training data of the regions of interest. In this example, I collected samples of bare soil, vegetation, and built up or man made structures. The Magic Wand tool will instantly segment these areas and provide corresponding measurements of each in square meters. The colors are manually chosen, but you can choose the appropriate hex code for each depending on how you want to classify your study area. The drone can also capture very high resolution images depending on the flight altitude and the objective of your research. If you want to identify trees in the forest, you can fly the drone at a lower altitude and then you can zoom into the leaves once you process the orthomosaic. Using the inspect tool, you can determine the coordinates of these leaves and even digitize them if needed in your GIS workflow. Some advantages of drone data include the frequency of data collection. It can either be daily, weekly, monthly, or quarterly. High resolution, cloudless aerial images, access to open and fair data, and multiple drone pilots can collect data. While some disadvantages include it covers a relatively smaller area compared to satellites, investment in drone pilot training for safety and to avoid flight risks, and drones cannot be operated in bad weather conditions. And these are the advantages of using GeoNadir in mapping plants in a forest over limestone. It can be used to detect anthropogenic activities such as quarrying, land conversion, deforestation, increase in human settlements, etc. It can be used to inspect post disaster damage such as fallen trees, erosion, flooding, burnt landscape, etc. It can be used to validate plant spatial distribution models. It can improve visualization of base maps and changes over time, and all data can be exported to QGIS and other GIS software. This paper is my reference for the webinar, and thank you for listening, and please join our FB group, Drones for Research, if you want to learn more. I will see you again in the Q&A portion of this webinar. Goodbye.